Everyone, welcome to my YouTube channel. Thank you so much for your amazing response, valuable feedback, and comments. As you all know, I'm doing quantum computing related podcasts since so many days. Thanks for your awesome response in this regard. Today, we are going to discuss one of the most crucial aspect of any technology. You take up it as a career. Definitely, you will feel that if I get good job in this area, I'll have more prosperity. That is genuine. Expecting a good job in the related area is always a gift for us. We are all waiting for that to happen in our career. In this regard, we are going to discuss what are the main job prospects in the coming days for quantum computing, how to fine tune our knowledge so that we can get a good job in this area, what certifications we have to do, what kind of additional knowledge we have to gain so that we can have a beautiful career in this area. So we have a very good expert in this area, none other than Dr. Swati. She is an IBM Qiskit advocate. She has done her PhD in the area of quantum computing, and she is always into this quantum computing area, giving her valuable inputs across the globe. Today, we are going to discuss some of the pointers in this 30 minutes of discussion. Don't miss any question, any answer, or any point during our discussion. Do follow us, do share your valuable comments, and if you really like that, please share this podcast with others. I don't want to waste your valuable time. Let us discuss all these things with our expert guest. Thank you so much, madam, for accepting the invitation. Can you kindly introduce yourself to my audience?
Sure, sir. And first of all, thanks for the opportunity. So, as sir introduced, I'm Dr. Swati Mummadi, completed my PhD in quantum computing and cryptography at National Institute of Technology, Karnataka, Surathkal. And currently, I'm working as an associate professor in the Department of Computer Science and Engineering, B.V.Raj Institute of Technology, Narsapur. And I'm also doing postdoc at Unimap, Malaysia, in quantum architectures. So, my complete research has I have started my research career in 2018 in quantum. So I first worked in quantum dot technology, and later when IBM has given cloud access to do the experimentation, then I've been shifted to the IBM cloud. So my complete research work and the current postdoc work is all I'm doing in IBM quantum cloud only. So, even in at Unimap, I'm working on quantum architectures, like where I'm covering quantum VLSI architectures for various applications. So, I'm also currently actively working on quantum key distribution. So, my actual research area in PhD is quantum error correction. So, all this, in nowadays, quantum error correction plays very important role because we are working with the noise intermediate scale quantum systems. So, without error correction, we can't even imagine the quantum systems. So now I'm extending my research work, like I'm applying quantum error correction for various applications, and also I've been applied my the implemented architecture of quantum error correction in quantum key distribution, where I could able to see the good results like when we compare to the existing state of the art works. So which the work also has been published in reputed journals, and also like currently I'm training few students in quantum technology. So they are working in quantum noise mitigation, quantum error correction, and also quantum machine learning. So currently I'm guiding a scholar, like he's doing PhD in quantum machine learning. So this is what even in our institute we are the quantum activities we are actively doing, and we are also even working with the foreign what do you say foreign companies like Q World and STELM Academy. So we have been collaborated with them, and we are also doing some collaboration work. I mean, along with that, we are also doing the collaboration work with the IITs. So a lot of work is going on because there is a lot of scope for the research in quantum area. And even today's podcast is completely on job role, like how students can get the job and all. So today I'll give the detailed information because most of the students are feeling difficulty in when we say the quantum, they are getting they are getting fear, like we need to learn many things and all, but it is not that tough. So it is easy. So I'll give you the all opportunities whatever we have, and we'll also discuss whatever the certification course we have in today's session.
Thank you
Yes.
so much. It is such a it is so much great statements. That is good to know, and your expertise will really help the current generation of students who are eagerly joining BTech courses, MTech courses, and also doing PhD as your scholar in the area of quantum computing. So we are eagerly waiting for your valuable inputs. So on that very positive note, Madam, my first question is what types of industries outside traditional research, such as finance, telecom, and cybersecurity, are currently hiring quantum professionals?
Yeah, actually, there is a lot of requirement in quantum, quantum jobs because industry started working on in quantum. But the major problem we are seeing in today's situation is like a lack of skill set. The students who are trained in quantum are less because even in our India, the quantum momentum has been started when the government, like central government, has announced quantum national mission in 2023. From then people started learning quantum basics, and even the count of students has been increased when we compare to 2023 to now. But like if we talk about the industries, like there is a lot of work is going on in, especially in security side, because like in I think most of you are already aware of like Google sycamore experiment, where they have been experimented with the shorts algorithm. They could able to break the RSA algorithm within 200 seconds, whereas supercomputer will take 10,000 years. That was claimed by the Google. So it has been done in 2019. So from then the perspective of the people has been changed. The people who thought like quantum is difficult, they thought of working in quantum because they attracted with this experiment. They wanted to know how exactly it is working. So few are curious and few are like how it is happening, like whether it is true or not, like to know that also people started working on. So that's why that experiment has been proven that with the existing of quantum systems, the current security will be in trouble because they could able to easily break RSA algorithm like integer factorization. They could able to do just in 200 seconds because all our security protocols are based on RSA and AS and various security algorithms. So once the system come into existence, like quantum system come into existence, all this will be easily breakable. So for that, the security industries, like many startup companies have been started even in India and also around the world. So a lot of research is going on quantum cryptography and quantum safe crypto systems. Because as I told you, once the quantum system come into like normal use, then it is easy to break classical crypto systems. If you could able to make it quantum safe, then there is a lot of scope. Like we need to make it because if security is in trouble, means entire nation will be in trouble. So that's why even government has taken a forward step. They have been given 6,000 crores for the quantum research. So they are working on making quantum safe security mechanisms. So as I told you, the companies or the industries which are working in cybersecurity and cryptography, they are working on post quantum cryptography and also the quantum cryptography. Again, these two are different areas where quantum cryptography is completely a cryptography protocol which will be experimented on quantum platform, whereas post quantum cryptography is like if you wanted to make classical cryptography quantum safer, then we need to modify that. Like we need to do the mathematical modeling where we can make classical crypto systems into quantum safe. So that work is going on in post quantum cryptography. So there are many industries which are working in these areas. Apart from that, there is also a requirement in machine learning because now a lot of work is going on quantum AI and quantum machine learning. The companies like Google, IBM, many companies, like even many startup companies are working in quantum machine learning. They also need the skill set who are good enough in quantum computing and also in machine learning. And also, like if we talk about the optimization, logistic optimization, like where we can do the optimized optimized routing things, there we can apply the quantum. We can see more efficient results than what we are seeing today in classical routing algorithms. And also we can apply it in aerospace for the optimized routing, because there also we require optimized routing. And apart from that, we can also apply it for the financial, even in finance, for the portfolio optimization, and even for logistic optimization. And if we see the applications like drug design, and also if you design different molecules and all, we need quantum because there, like we are already doing work with classical computing, but if we apply quantum principles, we can see the better results than what we are seeing today in classical. So these are various industries. Apart from this, there are many other industries which have started working in quantum. And even if we want, like if we talk about automotive industries. Recently BMW has been given, like they have been shared that they started working on quantum technology. They are integrating quantum technology with the like as I told you, like we can do the optimized routing, so they are applying that for the optimization in routing and also for optimization in controlling, like vehicle controlling, and even for the betterment, like even in automotive vehicles they are using machine learning. So they're also trying to integrate quantum machine learning. So they are also in research state, like they started working on now. So everybody understood that like there is a lot of advantage with the quantum principles. So if we could able to apply that in the classical applications, whatever we are doing today, we can see the better results. So this is like these are some industries which are working, as I told you. But apart from that, many other people are working. So there is a lot of requirement for the like if the people who wanted to start their journey and they are thinking that there is no job opportunity in quantum, this is not true actually. So you can find many jobs. There are many jobs available even in our country and around, like even worldwide. So only thing is you need to proficient in quantum technology and quantum basics along with the classical programming also required for that. So if you could able to manage these two, then you can find the jobs. Like there will be many jobs you can find.
Is know about these details, madam. What specific technical skills should beginners focus on to become job ready in the quantum domain?
Yeah, so if you talk about technical skills, again, they need to understand quantum principles first, because when we do the work in classical computer, simply we need to know what we wanted to do. Like simply we will do, for example, if I wanted to develop some algorithm, I will just understand what to do and what could be my output. But here we no need to learn about classical computer because we are already aware of like how the computer will be, how are the internal parts, how what are the functional units. We are already aware of. But in quantum, we should first of all understand how quantum system has been built, because the complete hardware infrastructure of classical and quantum is completely different. So you need to understand that, and even quantum computer has been designed by using the quantum principles like superposition and entanglement, so on which entire quantum is dependent. So these are the advantages which we don't have in classical. So obviously classical and quantum are completely different, you cannot compare both. So, first of all, you need to understand quantum principles, how quantum system works, what are the internal architectures we have, and then you need to have some mathematical, like basic mathematics, like linear algebra. You need to be aware of, and also you need to aware of complex number system, and also probability and statistics, because the entire the quantum operations are based on probability. Like if we measure the outcome, that will be based on probability. So you need to aware of all those basic mathematical modeling. And apart from that, you also need to be proficient in Python, because at present most of the quantum platforms are designed or are based on Python programming. So I know like everyone are currently working on Python. So if you have that proficiency along with some mathematical the basic knowledge, then you can easily start working in quantum, and even you can get the better jobs also in this. But apart from that, you also need to aware of how to use quantum cloud, because now if you wanted to experiment in quantum platform, you need to either simulate, like you have to develop the architectures or algorithms, and you have to run that in quantum simulator and also on real quantum system. So you need to aware of how to use the quantum quantum cloud platform. There are various companies which are giving the cloud access for the real system also. So if you are aware of all these things, then it's easy for you to start your journey, and also easy for you to get the job.
Madam, how important is the proficiency in Qiskit for securing roles in quantum software, research, or applied engineering?
Yeah, so proficiency in Qiskit is important, because if you are starting learning or if you are using IBM platform, you need to learn Qiskit, because we don't have any other option to do or to develop the experiments and run the experiments in real quantum system. But apart from that, we also have some other platforms also. You can even like based on your comfortability, you can go with any of the platform. But I'm completely working on Qiskit. So when as I told you, like even my quantum research has been started in Qiskit platform itself. So for this, you need to learn, as I told you, you need to understand what are the quantum libraries we have, Qiskit libraries we have, and you need to be clear with the functions what we are using, and even sorry, and also you need to be clear with like how to use the functions and how to write the programming. And as I told you, the base is Python, but you need to use the libraries wherever it is required. Like for example, to develop the quantum circuit, how to write the program, and to run it in a simulator, how to represent that, and to run it in a real quantum system, how you have to do. You have to be clear with all these things. So once you are aware of all these things, then it is easy for you to start building your own architectures, or you build, developing your own algorithms. Then you can easily like continue the journey. And I mean, based on that, you can also apply for the like jobs.
Quantum computer applications are structured learning paths generally increase job prospects today because people are aware of Microsoft certifications, AWS certifications, Google certifications, but quantum is a new field. So, what kind of certifications will
Yeah.
get them more job opportunity?
Okay, so like there are various certifications are available, as I told you earlier. Like even I like currently many companies are working on quantum. So even IBM is giving certification, like they are providing the free courses, free certifications, and also there is a the quantum developer certificate provided by the IBM. So there is some you need to pay some amount for the test, like it is a procurement exam. If you do that, then you will be recognized quantum like developer. So with that, you can apply for the jobs in IBM. So that is like I mean, it is I mean, they are providing all the material. You can prepare and you can attempt the exam. And apart from that, there are like foreign universities like MIT, Stanford. They are also providing the certification courses. So there will be some duration. So few universities are providing 6 months course. So they will teach you like from basics to the application level. So even you can do the certifications in that. And apart from that, if we talk about our India, in our India, like IITs are providing certification courses. So there are certification courses in quantum computing and quantum machine learning, which are of 6 months duration. So they are teaching you from the basics to the application level. So like all the certifications will be useful when you are trying to apply for the job in the quantum field. So obviously, when you are trying to apply, you need to showcase your expertise in quantum. So that may be in terms of publications or in terms of certifications. And also, if I wanted to talk, only certifications are not sufficient. Along with the certifications, if you do any real-time project or any small project kind of thing in quantum platform, then that will add more. Like that will be more effective and will be added to will be more useful when you apply for the jobs. So apart from that, like as I told you, many companies are providing the certifications now. Many startups have been started, and they are also training the interested students and also the interested researchers, and they are providing the certifications apart from based on their performance. So these are like you can concentrate more mostly on the company certifications like IBM, Google, and Amazon. They are also providing the certifications, and IITs and foreign universities. These will be considered more when you apply for the job.
For someone without a PhD, what realistic entry level roles can they target in quantum ecosystem? Because there is a myth in the mind of students and people that if somebody is having PhD in the hand, that is what is meant for quantum job roles. But what do you say about this man?
Yeah, that is true, sir. Like now people are thinking whoever done PhD, they only will get the job, they only will get the opportunity. But as you said, that is a myth. There is lot of the job opportunities which are available, because as I told you, if the number of companies or industries working in quantum technology, obviously there is a requirement in there is a job scope, right? So quantum, like whoever done the PhD, they have the roles in research, and they have also in like quantum development and all. But the people who are started learning in quantum, or who are interested to work in quantum, they can also apply. There are roles like quantum software developer, where they need to have a proficiency in Python, and along with some quantum basics. If not, also they will like while working they can learn and they can start doing that. And apart from that, there is also, as I told you, like we are working with the quantum cloud, even IBM and Amazon. So if someone proficient in cloud access, or if they could able to work with the cloud, like classical cloud, they can easily apply for the quantum. So even how to maintain the cloud and how to maintain the workloads, if they could able to do that, then that will be helpful. And apart from that, they can also concentrate on quantum machine learning jobs. If they are strong in classical machine learning, then they can apply for the quantum machine learning, where they can integrate quantum computing with the classical machine learning models. So these are the roles. Without having a PhD also they can apply if they are proficient in classical methodology. So like we have error correction rules, like quantum error correction. So to do that also they need to be proficient in classical error correction. If they have an idea, then if they understand what is classical information is, then they can easily integrate both, like classical and quantum, and they can apply, and they can also come up with new algorithms. So that's why, like, it is not, PhD is not only mandatory thing, but if you are really interested, then you can start learning quantum basics, and you can build it as a career in quantum technology.
Yes. How can software engineers or developers transition into quantum roles without completely shifting their career path? Because I have heard some questions from software engineers in data science, software engineers in artificial intelligence. They are asking me, like, if I want to do my career shift to quantum computing, what should I do? So, how do you suggest them, man?
Yeah, so there is, like, if they want to do the career shift, as I told you in, like, the continuation to the previous talk. So, like, if they are good in machine learning, if they wanted to move to the quantum machine learning, so it is not that difficult for them. Like, they need to understand some quantum basics, and they need to understand how quantum machine learning algorithms are working. So it is easy because they already worked with the classical machine learning. So it won't take much time for them to understand how classic quantum machine learning will work. So, but only thing is they need to spend at least 3 to 6 months time to understand the quantum basics and some mathematical modeling. If they could able to do that, then it is easy to like shift from classical to quantum industries. And even if I talk about the cyber security or cryptography, because we have many companies which are working on security, so they already have enough knowledge of classical security. So if they could able to understand quantum principles, and then they could able to, like, these, like, whoever wanted to convert, transfer from classical to quantum, for them they have an advantage. So they will be good, they will be having good knowledge of classical information, whether it is security or machine learning or even finance, or like they have done in classical perspective. So when they learn the quantum, they will get the idea like how we can make the quantum, like new quantum algorithms, by thinking classical perspective in their mind. So if because quantum is also in the infant stage, the research has been started. There is, like, in all the areas we have still research is going on. So there is a lot of scope if they apply some classical perspective, and if they modify that in quantum like quantum terminology or quantum information, then there will be a novelty, like there will be some innovation. So they can come up. Actually, there is an advantage who wanted to transfer from classical to quantum. So they have classical good knowledge in classical perspective, whatever they are working in. So they can apply quantum methodology, and they can even try how to convert that particular classical into quantum. So this is like where they can concentrate. So who are working in machine learning, they can easily start working in quantum machine learning. Even who are working in cyber security, they can work in quantum cryptography or in post quantum cryptography. And also who are working in finance, they can also apply quantum technology for portfolio optimization and also for the various applications. And similarly, like who are working in automotive, they can also see where they can apply the quantum. So it is not that tough, but they need to spend at least few time to understand quantum basics. So without understanding quantum basics and quantum principles, it is difficult for them to apply that in classical, like whatever they want in the required applications.
Let's start. So, how can it's effectively demonstrate hands-on skills like QKD implementations or quantum algorithm development during interviews or portfolio reviews?
Yeah. So what they can do is like whenever we'll go for the interview, usually we'll give the CV. Like we will submit the CV, and based on that, they will see what skills we have in that particular area, and accordingly they will select. So the preliminary selection will be done, and then there will be an interview. There you need to showcase whatever the skills you have in that particular area. So what I suggest the people is now we have the social media where they can showcase their expertise in any of the area, not only in quantum. So who are working in classical applications, they are also showcasing that in the social media, like for example LinkedIn, which is a like a professional platform we have. So what they can do is they can start working on quantum platform, and whatever the code they are implementing and whatever the projects they are doing, they can make a small video and they can upload it in a platform, or else they can even use that as a proof for their work. And along with that they can also show like the quantitative results. Like for example, even if we talk about the quantum projects, we will measure the results in terms of fidelity. If they come up with the good fidelity, if their application or if their algorithm is producing the good fidelity in terms of exact quantitative like results, like 15%, 20%, whatever they are getting, if they could able to show that in CV, then that also will show how they are like working, and how with like what they are exactly working, and how much better results they got. So all this they can showcase either in social media platform, or else like they also need to like whatever they are showcasing CV, that is fine, but they need to talk everything in interview first of all. So whatever the project they have been implemented, they need to be clear with it, and they need to explain that in detail in the interview. So communication skills also very very important. So the problem we are seeing in most of the students is like they are unable to communicate properly what they are doing. Even though they are doing extraordinary work, they could not able to showcase that. So this need to be done, and even especially in QKD and in quantum algorithms, whatever they have been developed. In QKD, the major parameters are like error rate and also key rate. If they could able to increase the key rate, then that also one achievement that also they can showcase. And if in quantum algorithms, if like even like in recent days, a lot of research is going on, and the industries are coming with new algorithms which are outperforming the classical algorithms. So if they could able to get any good results compared to the existing state of the art, that also they can showcase, and they can talk about all these things in detail in the interview. Then only the interviewer can understand how good they are in quantum technology and how knowledge they have. So these are the some tips I can give. Like apart from that, like first of all, you need to showcase whatever you have the knowledge. And one thing is, if you wanted the job in quantum technology, you just do some projects instead of doing only certifications and all. Do small project, and then only you will understand the like how the quantum principles are. We are saying that like everything is depend on quantum principles. So then only you can understand how you're getting the output. How like because when we are working with the real quantum system, we have a lot like the major challenge we have will be is internal noise. So, for example, let us say I'm just implementing some BB8 for QPD algorithm, or let us say some small algorithm have been implemented in quantum. So you can prove that in two ways. One is you can do the mathematical modeling, and second one you can do the experimental analysis. So where you can run, you can build that and you can run it in real quantum system. So, for example, like when you do the mathematical modeling, you may get the 100% accuracy, like final outcome may be 100% accurate. But when you develop that and run it in real quantum system, it may not be 100% due to the internal noise. So that is what we have the problem now. So that's why we are calling the current quantum systems as NISQ quantum systems, nothing but noisy intermediate, like noisy intermediate scale quantum level. So we can't, noise is by default is there with the qubits that we cannot do anything with. But if you could able to develop some noise mitigation algorithms, or like you can even apply those, if you could able to show that like without noise mitigation or algorithm, like what is the outcome, and with noise mitigation, how accurate, like how it has been like increased. So if you show that difference, that also a novel work. So there also you'll get the opportunity, because noise mitigation is required for all the industries who are working in quantum. Because without noise mitigation, because main the problem is like noise mitigation is leading to the error correction, sorry, errors, quantum errors. So again we need to apply quantum error correction mechanism. So if you could able to reduce the noise, all this will be reduced. So there
Yes.
you can concentrate, and if you talk like whatever the project you have been implemented, if you talk technically, and if you show your results in a quantitative way, then there is a lot of possibility for getting the job.
Perfect, ma'am. You have nicely explained all the showcase methodologies in the interview. That's really awesome. Thank you so much. As you told, the students are unable to express themselves when it comes to reality. So, what soft skills are most valuable for success in quantum research and industry collaboration? Maybe it is little bit out of box kind of question, but we need to also focus on this when it comes to job.
Yeah, true, sir. Like skills means, like as I told you, like first of all, the main thing they need to be clear with is quantum principles, like quantum information. If they could not able to understand the difference between classical and quantum, it is difficult for them to continue their career in quantum technology. So they first whoever, like even in my case, if I wanted to talk, like when I started my research career in quantum, I started learning, like I almost spent 6 months to 1 year for learning the quantum basics, because in 2018 it was too early to start the quantum. At that
Yes,
time we
yes.
don't have much
Yes, ma'am.
platforms or much data available. So even in our India, most of the people at that time were working in quantum physics, quantum mechanics. So in computation, very few were there, and only few universities used to work at that particular time. So even getting the data or documents, because if we are searching about quantum now in Google, we can find a lot of data. But
Yes,
at
ma'am.
that time, it was difficult. So I used to attend the foreign workshops, like the foreign country people who are used to conduct the workshops at midnight, like at 2 o'clock, 3 o'clock. I used to attend, and because they used to work on, because they had a quantum hardware at that particular time. So the universities like MIT and all, they had a platform. They started working in quantum computation. So I used to attend those, and I used to interact with the faculty, the speaker. I used to ask my questions. They used to give me some, like they used to clarify, and based on that I used to get some idea, okay, we can work in that area or we can work in this area. And later on, even in our India, I used to work, like I attended many IIT and NIT workshops which have been conducted in quantum computing. I interacted with most of the faculty at that time, like professors and all. So we had a lot of discussion. So I spent almost 6 months to 1 year for learning quantum. So if you're strong with the quantum basics, then it is easy for you to understand where you wanted to go. Like for example, if you wanted to work in so and so area, I need to understand exactly what is the requirement in that particular area, what is the research scope in that particular area. So can I do that or not? First of all, so whether it is feasible or not. So I need to understand all these things first. So first you spend a lot of time in learning the concepts. So if you are strong with the basics, then you can do whatever you want. Like it can be machine learning, quantum machine learning, or it can be quantum cryptography, or it can be quantum optimization, quantum architectures. You can do anything, but you need to understand quantum. You need to understand quantum information first, and also you need to understand quantum architecture, how quantum system has been built, what are the internal architectures, how the data will be transmitted from the classical to the quantum processing unit. So how the data will be converted, how the qubits will be converted into microwave signals. So all this you need to be clear. Then only you can develop the algorithm for whatever the problem statement you wanted to work on. So I suggest you to first work on the quantum basics and understand some mathematical modeling. Because if you see the papers, if you wanted to start the journey in quantum, you need to go through the state of the art papers, like which have been published. So if you see most of the papers, like 90% of the papers will be what we say, like explained using the mathematical modeling. There will be lot of calculations, a lot of mathematics. So if you are unable to understand those mathematical calculations, then it is difficult for you to understand what is happening in that particular paper. So that's why basic mathematics are important. At the same time, understanding quantum information and quantum basics are very, very important. So if you are strong with this, then you can apply, as we have many platforms, you can start working on any platform. So for that, as I told you, Python is compulsory. Like most of the platforms are designed by using the Python. So because most of the students, like who are doing BTech or who are completed BTech, they are aware of Python because they have that course in their BTech. So already they are aware of that, so they can understand how, if they can understand how quantum libraries are working, then it is easy for them to start working in quantum projects. But I suggest the students or whoever wanted to start the journey in quantum, try to spend some time in learning quantum basics. It is like if you understand that, then it is easy for you to like do research in any of the area in quantum. So this is what I wanted to share.
Make them more input in terms of their soft skills also. So, madam, what common mistakes do candidates make when applying for quantum roles, and how can they avoid them?
Yeah. So here, like even I came across few experiences. Like I've seen few students. Like the what is happening here is they will simply see the like quantum machine learning, or simply they'll see the job role, but they will not go in description. In description, whatever they want, they need to be clear with. Like even this student, so simply they'll say like they have done some FDP, or they have done some paper publication, or like if they have started learning, they will feel like they are eligible for that particular job role. But they need to go with the description, what exactly company is wanting under that particular job role. So if their profile is not matching to that, better not to apply, because even after applying also, even if you get shortlisted also, it will be difficult for you to clear an interview. So you need to be clear with the job roles, and also you need to be clear with the like cloud access. Like you need to be experienced in quantum cloud access, like how to use the quantum cloud access, whether it will be IBM or Amazon or whatever. Like you can, but you need to be experienced in that particular thing. Then only you can talk something in interview. Then only you can apply for the job. Even like you need to be aware of how to develop the algorithm in quantum platform, how to run it in a simulator and also in real quantum system. If you don't have that experience, then if you apply for any quantum role, it will be difficult for you to get the job. So first of all, you need to have a strong basics of quantum, and then you need to be clear with what is job description is. Whether, because in quantum again we have many like as I told you, like in classical we have multiple domains. Similarly, in quantum also we have multiple domains where we can work. You can work in quantum cryptography, or quantum machine learning, or quantum finance, or quantum optimization, quantum architectures, quantum key distribution. So if you are strong in quantum key distribution, then that will not be sufficient for quantum machine learning job role. So you need to be clear. So what is the job role? For that, what skills you need to have, whether you have that or not. If you don't have, better to improve your skill in that particular area and then apply for the job. But simply by seeing the name, don't go for applying. Even you got shortlisted also, you'll get difficulty in interview.
Yes, madam. So job description is very important, madam. That is really wonderful suggestion, madam. I have seen today that Andhra Pradesh has initiated 50,000 students training for quantum computing. So such kind of news are coming. So how do you foresee the fastest growing job opportunities emerging in the next 3 to 5 years? Because now we are in 2025. So how do you foresee in 2028 or 2030? What would be the status of quantum computing?
Yeah, actually, we should thank AP government because they have started Quantum Valley. So due to that, people could able to many people are aware of quantum computing. But before that, people used to think like quantum is difficult. It is difficult to go in that particular area. But when AP government has started that initiative, and they started like training programs for the faculty and also for the student. So as you said, their target is for training 50,000 students. That thing is going on because recently I've been attended as a jury for a Quantum Valley Hackathon semi-finals. So even there I've met many students like who came for the various places in AP, various colleges from the AP. So there I could able to see they started just, only for the hackathon. When they could able to see that particular hackathon notification, then only they started working in quantum. But they have explained very well, like okay, like they have done hard work, even though they need to do some more work, but they have started their journey. They could able to understand what they have to do, and they could able to articulate it very well in the presentation. So that is happening. And even like as I said, like in 3 to 4 years we can see everywhere quantum. Like it is like initial stage of machine learning, like how now machine learning is occupied every domain. Like everywhere we can see the machine learning, we can see the applications of machine learning. Similarly, quantum can be applied in any industry. It can be cyber security, or it can be drug discovery, like drug implementation, new drug designs and all. And it can be like finance, or it can be in machine learning, and it can be in aerospace, or it can be in automotive. So automotive industry. So everywhere we have the application, but only thing like we are lacking with the skill set. So that government has taken step, and they started training the faculty with the training programs which have been conducted by the MNIT Jaipur in collaboration with IIT, various IITs and all. So these things are going on, and at the same time they're also training the students. Various hackathons they are conducting. So obviously, if there is an hackathon, they have to sit there for 24 hours or 48 hours based on the duration of the hackathon. So in that particular duration, they will be having a lot of time to learn. So even though if they are not good with the quantum basics, they will learn hackathon by having, like, they can form a network with the other college students who are working in quantum area. They can meet the jury members, they can have inputs from them. So it will be a very good chance for them to start learning, and also to learn new things. So now, after 3 or 4 years, like, there will be a lot of job opportunities in quantum, and also there will be a lot of startup companies. If I see from 23, like now in these 2 years only, a lot of startup companies have been started in quantum. It can be in various areas, but they have started working in quantum. So one more thing is like quantum semiconductor technology now, even, which is booming, because even semiconductor industries are integrating quantum into chip design. So that is also happening. So even Intel, they are working on that. Many semiconductor companies, because due to this, the requirement of the manpower is increased in all the industries. If the students are skilled in quantum, then they can easily get the job. So for that, first thing we have to do is train the students. That has been started. So even many colleges are conducting FDPs and student development programs, so that they can train the students and also the faculty. Now even students also showing the interest in learning the quantum. They understood like how it is important when we talk about the industry perspective. So they are also learning, they are also showing interest, and they are also very serious in starting their journey or in career in quantum.
Actually, I wanted to know your journey, because you told, as you we all know that in 2018 there was nothing like this in the area of quantum computing.
Correct.
So, what inspired you to take this as a research work? Because doing PhD is a very tough task. As I know, I have done it. So, how did you take up this rare area in 2018 and finish your PhD? What was your inspiration, man, to take that up?
Actually, my inspiration is my husband, because he predicted all these things in 2017 itself. Because even
Okay.
at that time, I'm a computer science faculty. He works in electronics and computer science, EC department. So
Okay.
at that time, like, even I was interested with the digital logic circuits and all. So even he's very good in VLSI design, so he's a trainer. So actually his name is Dr. Gnaneshwarachari. So he is also professor in the same college where I'm working. So
Okay.
like in 2017 we combinedly started working in quantum, and we first worked in quantum dot technology. At that time we had tools for quantum dot technology. We didn't have this cloud platform, we don't have IBM and all those at that time. So even we published a paper on that. Like when we started working on that, we felt it is interesting, because it is completely new and there is not much data available. So we felt it is challenging, and we felt it is interested. So however, like, we both are at home, so we used to talk about that, we used to start working in that. So late I got a paper on that, so we published a paper. And later on, I got a full-time PhD offer in NIT Suratkar. So based on that work, what I've done in quantum. So there, even even in my even in my department, also I'm the first who started in quantum. So like I joined in 2019 there. So even at that time also, it is very new for them. Like even not much people are knowing about the quantum. I mean, even they also asked whether it is like whether you could able to experiment on real system or not, because without the proper experimentation we can't get the PhD degree. But
Yes.
luckily in 2019 we got the cloud access. IBM has been announced cloud access for their real quantum system. So that had helped me to start my research in computation side. Because in quantum dot technology, mostly it is like electronic kind of thing. Like we used to have electronic particles which we used to represent in quantum dot technology. So there we could able to implement some architectures and some circuits and all. But later on, in when IBM has provided the access, I started developing applications or the circuits for quantum computation. And then like my major area was quantum error correction at that time, because as I told you, error correction was very important in quantum computers. So I started working on developing novel error correction methodology or algorithm. And then I've been applied the developed error correction in quantum key distribution protocol. There I could able to see the very good results without error correction when I compared with the proposed error correction model. And later on, like it has been started. I mean, even I was like, even today also I feel like how we have started in quantum, because at that time it was very new, like
Yes.
not much people are aware of, and even most of the people doesn't know that we have the IBM cloud and all. But
Mm.
later on, when government has after national quantum mission, most of the people got know that like we have a platforms available, we can work on real quantum system also. So this is how our journey has started, and it has taken me to the postdoc also. Like even I got the opportunity in quantum architectures, where I'm working in quantum VLSI architectures, especially. So I'm working with the UNIMAP Malaysia University, and even in our college also now the students who started working in quantum has been increased, and they are showing the interest. They are coming to me and they are asking like, we are interested in quantum, and please train us so that we can continue our journey. So it is happy to see such kind of different, like the change in the time, like so in 2019, if we ask also, people were not interested, but now they are showing the interest, and they are learning, and they are searching for the jobs in quantum. And like one of the student who worked under her, like us in 2018, like we started with one student, he's working in MIT now. So we are
Oh.
happy. He's working in quantum computing lab at MIT. So we are even
Uh-huh.
happy for that. So this is how suddenly our journey has started, and it is continuing.
Super, madam. Thank you so
So I
much.
should thank actually.
Yeah. Thank you so much, madam. Really, you have given wonderful insights, very valuable pointers you told. If the students really listen this podcast from beginning to ending, they will get all the important points to get a good job in this emerging field. Because in universities, private engineering colleges, they are starting BTech quantum computing. Even in IITs and other premier institutions, we are seeing it is already running. So all of them are very eager to know all these points which you have covered. Thank you so much, madam. It was really awesome to interact with you. And once again, from my bottom of the heart, thank you so much.
Thank you so much, sir, and thank you for giving me this opportunity so that I could able to share some insights. I mean, this is not like the. I mean, there is a lot of data available. Like even they can like if any are interested, we can also have a detailed session also in case if any students want. Because like I mean, there are a lot of opportunities now. Who are interested, just simply go and start your journey in quantum. Learn something in, like start something in quantum, then automatically interest builds, and you will learn what is happening. And then you, I mean, because quantum is completely depends on interest. So without interest, no one can continue their journey in quantum. So that, like when you start learning and when you talk about superposition and entanglement, few students will start curious about that, how it is happening, because it is completely new to us. In classical, we doesn't even know, like that concept is not there. So how superposition is happening, why two qubits will be in same state, why, what is entanglement, how those two will be connected. So when we talk about all these things, they will get interested, like they will get curious, like they wanted to know much, like how we can entangle two qubits, three qubits. So they started experimenting, and then they will start their journey in quantum. So that's why first you need to have a interest, and with the interest you start just learning the basics, then automatically that will take you to the outcome will be not even like what you expect. So once you start, obviously there will be a very good outcome, and there will be very good opportunity outside. So many companies are waiting for the skilled students or skilled persons who are having a good or strong basic knowledge in quantum. So you just start learning. That's it. That is what I can say now. So once you start, automatically you can understand like how you're going, like how it will take you to the next level.
Exactly. As you rightly told, if the students definitely learn with interest, as you told, the destination we can even we cannot imagine how it will be. So that's really right, madam. Thank you so much
Yeah.
once again for your valuable inputs.
Thank you, sir. Thank you so much. And thank you so much for giving me this opportunity. And yeah, so like you be in touch with me. Like if any of you are having doubts, like whoever seeing this podcast, if you want any clarification regarding this, you can even contact me through LinkedIn, or yeah, you can even reply to this YouTube video also. I can give the reply.
Definitely, madam. Thank you so much.
Yeah. Thank you, sir. Thank you so much.
Thank you.